Then the girl in the corner with the scarlet letter. While you're watching, you may think that she doesn't matter, but no one knows you better.
Hi guys, I'm Jubel Laria and this is the summary of Chapter 6, the network layers. So the network is the application service of one end device can communicate with application. So the protocols of the OSI model network layer specify addressing and process that enables transport layer data to be packed and transported. The network layer encapsulation enables data to pass the destination within a network. So the next is the network layer. To establish the end-to-end transport, the network layer uses the basic process, the addressing and devices that must be configured with the unique IP address. The encapsulation is the process adds in IP header information such as IP address or sending the destination and the receiving. The routing travel to another network, the packet must be processed by a router. So it process known as routing the packet cross to the destination host, the encapsulation. If the destination IP address within the header match its own after the packet, the encapsulate by the network layer, the resulting layer 4. Next is the network layer protocols. We have two network layer protocols, the Internet Protocol version IPv4 6 and the Internet version 6 IPv6. So the encapsulating IP, this header is used to deliver the packet data to the destination host. So the process of the encapsulating data layer by the layer enables the services at the different layers to develop the scale without affecting the other layers. So the routers can implement perform by this intermediate devices used and consider the contents of the network layer header. Next is the characteristics of IP is the packets from the source of destinations over the interconnected system network of networks. Next is the IP connectionless. The data communication work on the same principle. This process greatly reduces overhead of IP and non-pre-established end-to-end connections sender are unaware whether the destination device present the functional. So the IP best effort delivery, they contain no information that can be processed to inform the sender whether delivery was successful, and out of order packets are delivery or packets missing, then application using the data or upper layer services must resolve the issues. Next, the IP media independent. So this it is responsibility for the OSI data link layer to take an IP packet to prepare its transmission over the communications medium. This means the transport of the IP packet is not limited by the particular medium. And next, in the control communication between the data link layer and network layer is the established for maximum size of the packet. The data link layer passes the MTU value of the network layer. Next is the IPv4 packet header. So it consists the fields containing important email information about the packets. So the IP protocol header diagram, the figure identifies the fields of the IPv4 packet. The versions, the version is set of 10100. The identifies of IP version 4 packet. The differentiated services field is 8-bit field used to determine the priority of each packet. The time to live is contains 8-bit The packet sender sets the initial TTL value, and the protocol is used to identify the next level protocol. This is 8-bit binary value indicates the data payload. Next is the limitations of IPv4. IPv4 still has three major issues: the IP address depletion, the increasing the number of new IP-enabled devices, always out connection, and to potential growth of less developed on the regions, and the internet routing table expansions. Best path for determination: as the number of the servers connected to the internet increases, so too does the number of network routers. So next, the lack of end-to-end connectivity is the implemented within the IPv4 networks that provides a way for a multi-devices to share a single public IPv4 address of an internal network host hidden. Next is introducing IPv6. The improvements the IPv6 provides include increased address space based on the 128-bit hierarchical addressing opposite, and the improvement packet handling is simplified the pure fields that eliminates and the need for NAT, such as large number of public IPv6 addresses that include application problems experienced by application. 32-bit IPv4 address space provide approximately unique addresses, and the encapsulating IPv6 is the options field and padding field as highlighted in the figure. For IPv6. Some fields have remained the same, some fields have changed name and positions. Next is the IPv6 packet header. The versions to identify this is the IP version 6 packet. The traffic class 8-bit field is equivalent to IPv4 differentiated services. The flow level is the 20-bit suggested that all packets with the same flow level. The payload is the length of the data portion of the payload. The next header indicates the data payload that packet is carrying. Enable network to pass data. The hope limit as when the content reaches the zero, the packet discard the IPv6 time exceed message is forwarded to sending host. The source IPv6 address is 128-bit field identifies, and the destination IPv6 128-bit field identifies IPv6 addresses of the receiving host, and the source IPv6 address is the sending host. The host forwarding decisions is the host that can send packet to itself, ping itself by sending a packet to special IPv4 address of 127.0.0.1. The local host is the sending host that share the same network addresses. The remote host is the host that do not share the same network addresses. So whether the packet destined for the local host or the remote, the subnet combination of the source of the sending device compared to the IPv4 address subnet mask of the destinations. So the packet is simply forwarded out of the host interface through the intermediate device and the destination devices directly. So the default gateway is the network device that can route traffic to other network. It is the router that can route the traffic of the local network. So a default gateway, the router's traffic to other networks, has local IP address and the same address range as the host on the network, can take data and forward data out. So they can talk to other people in the room or network, but if do not know the default gateway addresses. So using the default gateway is the dynamically from dynamic host configuration protocol configured manually. So having a default gateway configure creates the default route in the routing table of the PC. A default route is the route of pathway of computer will that tries to contract the remote network. So the host tables is the both commands generate the same output. The output they seem overwhelming at first fairly simplify understand. So the TCP/IP network connections have three sections related to the current. So the interface list is the assigned interface number of every network capable interface including Ethernet, Wi-Fi, and Bluetooth adapters. The IPv4 route table is direct connections, local network, and local routes. The IPv6 the connection, local network, and local default routes. So the router packet forwarding is the determine where to send the packet to if the destination host is the remote the packet forward to the default gateway. The routing table router can store information about directly connected routers and remote routers. So the directly connected routers is the configure with an IP address is activate. Each of the router's interface is connected to its different segment. The remote routers is can be manually configured to local by the network administrator or dynamically configured by enabling the router to exchange routing information with the routers. Next is the IPv4 is the routing information for directly connected networks the and remote network and routing tables also information on how the route was learned, the trustworthiness and rating of the route. Next is the direct connected routing, the IPv4 address and the subnet mask. It's activates the following routing table that entities the automatically created. The C is created when the interface is configured with the IP address and activated. The L is the interface. This is the IPv4 address of the interface and the router. So that's all guys, the summary of chapter 6.